Section 5.1 Quadratic Functions. Given a quadratic function, how to find the domain and range. So in the past few sections, we used algebraic methods to find the domain. However, in order to find the range, we had to graph the function and look at the range from the graph and determine the range from the graph. For the quadratic functions, we will be able to determine the range when we find the vertex. When we find the vertex and determine if the parabola is open upwards or downwards, we will be able to determine the range algebraically as well as the domain. So the first step in order to determine the domain and range is to identify the domain of any quadratic function as all of the real numbers. So that does not change. It's a fact. We know that the domain of any quadratic function is from negative infinity to positive infinity, which is basically all of the real numbers. The next step, we're going to determine whether A is positive or negative. This is going to tell us whether the parabola opens upwards or downwards. So if A is positive, the parabola is going to have a minimum, which means it's going to open upwards like that, and we're going to have a minimum. If A is negative, the parabola is going to have a maximum, which means the parabola is going to open downwards, and we're going to have a maximum. Then we're going to determine the maximum or minimum value of the parabola by finding the k value of the vertex. So we have to find h and k one more time. So we have to determine the vertex of the parabola and then determine the k value, because the k value is what the range is going to depend on. If the parabola has a minimum, then the range is going to be from k to positive infinity inclusive of k. Basically, what this is saying, it's saying if A has a minimum, and then when you scan the parabola from the bottom to the top, here will be the beginning point, which is basically the k value, and then this goes to positive infinity. So that's why we have k to positive infinity. If the parabola has a minimum, then the range is going to be from negative infinity to k, which means the parabola is going to open downwards, and then when you scan from the bottom to the top, you'll notice that you're coming from negative infinity and you're stopping at this value, which is the value of the k. So that is how you're going to determine the range algebraically for quadratic functions. Let's look at some examples. Determine the domain and range of f of x equals 7 times x plus 3 all squared plus 2. So this equation is given in the standard form. Now I'm going to compare this to the standard form, basically. So we're going to say the standard form states that it is equal to a, f of x is equal to a times x minus h all squared plus k. So I can immediately solve for h and k. To solve for h, I will take x plus 3 and I will make it equal to 0. X plus 3 equals to 0. That will lead to x is equal to negative 3, sorry. X is equal to negative 3. In other words, h is equal to negative 3 in this case. Now, the k value is equal to 2. So k is equal to 2 by comparison. So the vertex is negative 3 and 2. Luckily, we do not need h in this case because we can determine k without the reliant on finding h first, because the equation in a standard form. So I'm just going to proceed here. The domain of the given function is from negative infinity to positive infinity. Now, since a is positive, I know that the parabola is going to open downwards, and the range is going to start from k, go all the way to positive infinity. So the range is going to be closed bracket from k, which is 2, all the way to positive infinity. Because if you scan it from the bottom to the top, the first value you're going to see is the k value, and then the function is going to continue for infinity. Question number 2, determine the domain and range of the function f of x equals negative 4x squared plus 16x minus 1. The first step I'm going to do is to determine A and B and C, and if we have a minimum or a maximum. So A is -4, B is 16, and C is 1. A is less than 0, which means we're going to have a maximum, and the parabola opens downwards. So I need to find K. In order to find K, I need to find H. H is equal to -b over 2a, which will be -16 over 2 times -4. That is -16 over -8, which is equal to +2. The K value is f of H, which is in this case 2. So this is equal to -4 times -2 all squared plus 16 times -2. There's no negative here, just +2. 2 plus 1. So we will have -4 times 4 is -16 plus 32 plus 1, which will be equal to 16 plus 1, and that will be 17. So in this case here, the domain is all of the real numbers from -infinity to +infinity. Let me change the color here. And then the range is going to start from -infinity, and it stops at K, and K in this case is 17, and then close bracket. So that is the range and the domain of this specific function. Question number 3, find the standard form of the quadratic function that has a vertex of -3 and -3, and a point on the graph is -4 and -2. So the standard form is when f of x is equal to a times x minus h all squared plus k. We have h and k, so we're going to use them first. So the new function is going to be f of x equals, I do not know what a is, so I'm going to keep it as a. X minus h in this case is -3, so I'm going to substitute that here, all squared, plus k is -3 as well, which will lead to the equation f of x equals to a times x plus 3 all squared minus 3. Now, in order to find a, we know that the given point is on the graph, which means if we plug x and y instead of the x and y, here is x and y. If we plug x instead of this x and y instead of this f of x, then we will end up having an equation with one variable that we can solve. So let me do it in a different color. So in this case, f of x is equal to -2. I will replace it with -2, which is this value right here, equals a, I do not know what that is, and then x is -4 plus 3 all squared minus 3. And I'm going to simplify this. So -2 equals to a times -4 plus 3 is -1 all squared minus 3. I'm following PEMDAS here. The left-hand side will remain -2 equals to a times -1 squared is a minus 3. Now we're going to solve this equation. We're going to add 3 to both sides of the equation, so we'll end up with a equals +1, which will make the standard form that we're looking for is f of x. So I'm going to use this function right here, and I will substitute a with the value that we found. So it's going to be f of x equals to 1. Usually we don't write that. X plus 3 all squared minus 3. And that is going to be the standard form we're looking for. Okay. Question number 4. Suppose that the vertex and the x-intercepts of the parabola associated with a certain quadratic function are given by 1 and 3 and 4 and 0 respectively, which means the first one is the vertex, that is h and k, and the second one is a point on the parabola. Find the other x-intercept. So we were given one x-intercept and we would like to find the other x-intercept. Okay. So we know that the parabola, if we graph it, we know that the line of symmetry is h is equal to x is equal to h. So 1 and +3 is here, and since we have x-intercepts, I know that we're going to have a parabola that is opening downwards. So one of the x-intercepts are 4 and 0. What is the other one? So this line here basically is x equals 1, which is the line of symmetry. So if you count from 1 to 4, you will get 2, 3, 4. So 3 units to the right. I can take the same measure here. So 1, 2, 3 in order to go on the other side, which means this is going to be -2 and 0. The other x-intercept is going to be -2 and 0 by symmetry. So if you draw that on a grid, it's going to be a little bit better. And because I am not using a grid here, it's kind of a little bit messy. So let me try to fix that graph. Graph is going to pass through that point right here. But hopefully you'll see what I'm saying. So the other x-intercept is -2 and 0 by symmetry, basically. Find the equation of the parabola. We have the vertex, so we're going to plug it into the standard form. So f of x equals to a times x minus h all squared plus k. We will plug the h and k first. So f of x is equal to a, we don't know what that is, x minus h is 1 all squared plus k is 3. Now we're going to use the given x-intercept in order to find the a value. So we can do this by plugging 4 and 0 in here. So we're going to plug x is 4 and y is 0. So we're going to say 0 equals a times 4 minus 1 all squared plus 3. And that will lead to 0 equals to 3 squared is 9. 4 minus 1 is 3. Squared is 9. So 9a plus 3. We're going to subtract 3 from both sides. We will get 9a equals, make a like that, equals -3, which will give me, if you divide by 9 both sides, it will give me a equals -1/3. So the standard form of the function is going to be f of x equals to -1/3 times x minus 1 all squared plus 3. Basically what I used this function right here, and I substitute a with its value. So I got the final answer here. Now, if you would like to find the x-intercept that way, if you'd like to find the equation first and then you're going to find the x-intercept, that is another possibility as well, instead of using symmetry. So what you're going to do, you're going to make f of x is equal to 0, and you will end up 1/3 times x minus 1 all squared plus 3, and you're going to solve here for x, basically. So what you can do, you can first take 3 to the other side. So you're going to get rid of it, and then you're going to multiply everything or both sides by 3. So you're going to end up with 9, -9. You're going to multiply by -3, so you're going to get 9 equals, -3 is going to cancel with the 1/3. You're going to have x minus 1 all squared. And now you take the square root for both sides, so you end up with x minus 1 equals positive or -3. Now, one of the solutions is x equals +3 plus 1, which is 4. That is one of the ones that are given. And the other one is going to be x equals -3 plus 1, which is -2. And that is the other x-intercept that we found. So it doesn't matter how you find the x-intercept. As long as you use one of these valid methods, your answer should be the same and it should be correct.